Hey folks, how's it going? This is Mr. Moray. I'm coming to you with a brief little video on graphing absolute value functions. I thought I'd make a video just to kind of recap some of the important ideas that we discussed in class. So in thinking about this, I'm hoping to really hammer home some really important points that we want to think about when we graph absolute value functions. These kinds of ideas are going to come back over and over throughout the year, especially when we start to talk about quadratics, because what we're going to learn when we get to quadratics is that so many of these patterns that we're going to see are going to come back up again with quadratics, okay? And so that's why I know some of these rules can be confusing, but I really hope that you just stick with me. You have faith in me, like I have faith in you, and I promise you, if you stick with it and you trust me, that you're gonna be happy later on in the year when you see it come back up. Okay, so what we discussed in class, and remember, we know that y is the same thing as f of x. We know that in general, the general formula for an absolute value function is f of x or y is equal to a times the x minus h plus k. And this is just a fun fact. What we're going to learn in the spring, and I thought that I would point this out in this video, quadratic, that's a quadratic right there. So notice how strikingly similar they are. Instead of having bars with a quadratic, we have parentheses and a squared. But I'm going to promise you this, when we get to quadratics, the h and the k are going to play exactly the same role as they do in absolute value. I promise you. And the a will play a very similar role, okay? So anyway, this is the general form, okay? And remember, h and k, that's going to be the vertex of the parabola. And a is going to tell you the slope after you get to the vertex. And the opposite of a will give you the slope before you get to the vertex. But remember what I say in class. The only way without technology to 100% know you've got the right graph is to make a table. It's the only way to have a 100% correct graph. So in this video, what I'm going to do is I'm going to do a couple things for each of the functions here. And by the way, shout out, thank you so much, Kuda Software, for providing this amazing worksheet, okay? I'm going to show you step by step how we graph these out. And I'm also going to show you what it looks like on a calculator, right? Here's my calculator with an empty graph. I've set it up, all right, so that it can make a nice graph, and I'll show you the table, and I'll also show you what the graph looks like, okay? So here we go. The first function is y is equal to the absolute value of x minus 2 minus 4. And remember, y is the same exact thing as f of x. This is just y equals notation. This is just function notation. So remember, the first thing we always want to think about doing is making a table. Now I know people are like, oh, Mr. Moray, that's a lot of work. So here's where I push back on you. All right, so then if it's a lot of work, how about we work smarter, not harder, and find some really easy points to plug in. So remember what I said in class. The first thing we want to do, well, what's the easiest thing we can do? Let's try to cancel these bars out. Let's try to get 0 inside the bars, okay? So what would make inside of the bars equal to 0? All right, that number is going to be 2. All right, now 2 minus 2, that's equal to 0. All right, and 0 minus 4, that's equal to negative 4. And this is the vertex, and here is why. So basically, remember that an absolute value of a number is always going to be a positive number or it's going to be 0. And whatever positive number we get, okay, that's going to be being added on to this negative 4. Now remember, we're going to plug in a bunch of numbers, but only one number, when we plug it in, will be like adding 0 to the negative 4, and that special number represents the vertex. Let me give you another example. So I'm going to now try to do the next easiest point here. So I'm going to choose 3. Why did I choose 3? Because look, when I plug in 3 into the bars, I get 3 minus 2, and that is 1. okay? The absolute value of 1 is 1, and then 1 minus 4 is negative 3, okay? Now I'm going to plug in the number 1, okay? And remember, one thing we discussed in class is the symmetry. I know because 1 and 3 are the same distance away from the x of the vertex. Let me box this vertex. Because 1 and 3 are the same distance away on the x-axis from 2, they're going to have the same y value. But let's just see why that is. Let me show you why. Now look, if I plug in 1, I do 1 minus 3, and that's negative 2. And negative 2, rather 1 minus 2, I'm sorry. I do 1 minus 2, and that's negative 1. And negative 1, its absolute value is positive 1, and 1 minus 4 is negative 3. So remember, when I plugged in 3, I had 3 minus 2, and that was 1. When I plugged in 1, I had 1 minus 2, and that's negative 1. And remember, 1 and negative 1 give me the same exact absolute value. So let me show you what that looks like symbolically. So 1 went in, and what was left in the bars, it was the absolute value of negative 1. When 3 went in, what was in the bars was the absolute value of positive 1. And because these numbers are going to have the same value, right? This is equal to 1, this is equal to 1. Their corresponding outputs are also going to be the same. Because think about it. Once you get the bars, nothing else about the function is any different, right? If I get 1, I'm subtracting 4. If I get 1, I'm subtracting 4. That's going to give me the same outcome. So let's see what we have so far. We have 2, negative 4, 2, 1, 2, 3, 4. We have 3, negative 3, 1, 2, 3. And we have 1, negative 3. So folks, I'm really going to encourage you, look for the symmetry, because I promise you, the idea of symmetry works exactly 100% the same as it does in quadratics, okay? Notice we have this beautiful ax of symmetry. Let's take a look. And to show you, now I'm going to plug in 4, okay? And I'm going to plug in 0. Notice that 4 is 2 away from 2, and 0 is also 2 away from 2. Let's see what happens. When I plug in 4, what do I get inside the bars? I get 4 minus 2, and that's 2. What about when I plug in 0? When I plug in 0 in the bars, I get 0 minus 2, and that's negative 2. Now, look, what's the absolute value of 2? It's 2. What's the absolute value of negative 2? It's also 2. So think about it. The absolute values are the same. Nothing else about the function's any different. So that means I'm going to end up with the same exact x value. Okay, so I got 4, negative 2, and 0, negative 2. Okay, so again, now, folks, here's going to be my little question for you. Take a second and think about it. 5, let's plug in 5. So when I do 5 minus 2, I get 3. The absolute value of 3 is 3. 3 minus 4 is negative 1. Take a second and think about it. Which number, which x, based on the symmetry, is going to have the same exact value, y value, as when x equals 5. So which x has the same exact y value as 5? Okay, the answer is negative 1. Because think about it. Negative 1 is 3 away from the x of the vertex. 5 is also 3 away from the x of the vertex. So in either case, I'm going to get 1, or rather negative 1. Okay, now look, what's my pattern? Take a second, think about it. Based on this, what will 6 be? Okay, 6 is going to be 0. See how it's going up 1 and over 1? Now, this pattern will not be true of quadratics, but it is true of absolute value, so we should take advantage of that while I have it. And now what I'm going to do is I'm going to connect, and to make my buddy HB happy, okay, shout out to my buddy HB, I'm going to put arrows on the ends. Look at that beautiful V. Okay? So let's see what it looks like on the calculator. So we'll turn on our calculator, and we're going to hit the button y equals. Make sure you hit the button y equals. Okay? Now I'm going to do this function right here. So remember, you're going to hit math. Let's move up so we can see my finger here. Math. We're going to go over to number. And we're going to select abs. Okay, up. And I got to make sure that you're not on the equals. So let's try that again. So make sure your blinker is next to the equals. Math, over to number, abs. Now, notice how I had abs come up. That's totally fine. Sometimes you're going to get the bars, sometimes you're not. Okay, that's just how mine happened to look. And you know what? That's perfectly okay. Either you're going to have the bars or you're not. Okay, so in my case, I don't get the bars, and that's okay. So I'm going to press X. Okay, now let's look at my function. Minus 2. If you have the abs, you just then close it off, and that's the same thing as the bars, okay? And then minus 4. Otherwise, sometimes you're going to get the bars in there, and then you just make sure you have an X minus 2 in the bars, escape out of the bars using this little arrow, and then put the minus 4, okay? And we've done that a little bit in class. If you have questions, feel free to ask me about that. Then I want to show you two things. Really, really, really important, especially next year, guys, okay? Because this works for any function. We're going to press second. Okay, see my second? My up arrow. And then graph. Notice what just happened. It made a table for me, okay? So let's go ahead and take a look at our points. Notice 2, -4. I'm going to line that up. Look at that, okay? 2, -4, 2, -4, 3, -3, 3, -3, okay, 1, -3, okay, checking my work, 4, -2, 0, -2, 5, -1, and if you hit the up arrow, it will move up, -1, -1, beautiful, okay? Let's see what it looks like in a graph. So remember, second graph accesses the table, straight up graph accesses the graph. Look at this, wow. Nice, very nice. Let me see if I can zoom in on this. Okay, so it's a little bit difficult on this. I'm going to try to zoom in a little bit more. I've made a couple changes to my graph. Okay, and if you want to make it look like this, go ahead and press second, zoom, and that will open the formatting. So see, I set it so that I've got grid line. That's why those grid lines are showing. Okay, and I set my grid color to light blue. And if you just go and highlight it and press the left and the right, that's how you change that. Okay, so I'm going to go ahead and show you the graph again, and just needs to repaint the lines. Look at that. So I get a nice graph. You can see a vertex here at 2, -4, which is exactly what we got. Here's going to be my piece of advice to you. Do not rely on the graph unless you know how the graph is set up. So I can see here my graph is going from -10 to 10 on the X, -10 to 10 on the Y. It's going up by 1 on the X and up by 1 on the Y. But if I didn't know that, you don't know just by looking at the graph what the graph is going up and down by. So if you don't know that, you cannot trust the graph. The only thing you can trust is the table. The table is just what's going in, what's coming out. So be really, really, really careful when you do that, okay? All right, so here's what I'm going to do. I'm going to ask you, if this was tough for you, if you want to take another look through, another gander at that, go ahead, pause the video, okay? And then in a second, let me just quickly zoom in, and then in a second, I'll go ahead and move to the next problem. All right, so I know that was definitely a very long explanation on that. For that reason, I'm going to pick up the pace, and I'm slowly going to go faster as I go through them. Okay, so I'm going to do one more, and then I'm going to turn it to you for a you try. So let's take a look at this. Y equals x plus 1. So remember, the first thing we do is we make our table. Okay, now, my first thing is to cancel the bars. I want these bars gone. That's going to be the x of the vertex, okay? So to get these bars gone, what I'm going to do is I'm going to plug in -1, because what's -1 plus 1? It's 0. Notice now there's nothing off to the right, so as soon as I plug in -1, there's nothing to add or subtract once the bars are gone. So what represents nothing? 0. Now, let's use the symmetry. -1 is the x of the vertex, so I'm going to box that. So here's what I know. Let's look at -1. Let me make my little notch on -1. What I know is that 0 and -2 are both 1 away from 1. So they have to have the same y value, okay? Now, these are little tricks. Remember, if you make a table, hit the vertex and go boom, 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 and start plugging in numbers, you are going to eventually get the right graph. If you can learn little patterns, it'll save you time, because then you'll have to plug in less numbers to get the final answer. Notice I'm not using the A trick. Okay, I want to reduce memorization. I want you to have a couple tricks that always work rather than a few tricks that sometimes work, all right? So anyway, 0 and 2 is going to have the same out. Notice, what 0 plus 1 is 1. Absolute value of 1 is 1, and nothing to add on the other side, nothing to multiply. I'm done. How about -2? -2 plus 1 is -1. Absolute value of -1 is 1. So as you can see, same exact y. Now technically I would be done here. I'd like you to plot at least 5 points. Again, I'm thinking forward to parabolas. I want you to plot at least 5 to 7 points, because the more you can plot, the more accurate it's going to be. The up and down here is a very predictable pattern, but again, you guys are going to investigate much more complicated functions next year. And so what you need to know is the more points you put on, the better graph you're going to have. Okay, I need you to trust me on that. So again, let's take a look. Symmetry, buy one, get one. 1 is going to have the same x as -3, because 1 and -3 are the same distance away from the x of the vertex. And I'm going to use what I might call the little adapted May method. I'm going to draw my dotted line through the vertex, because that represents the axis of symmetry. And fun fact, the axis of symmetry is x equals -1, and the -1 comes from the x of the vertex. The x equals because it's a straight up and down line. All right, so anyway, 1 and -3 will have the same y. I plug in 1. 1 plus 1 is 2. Absolute value of 2 is 2. Now, I already know that -3 is going to have a y of 2. And what's good about that is sometimes we get confused when we work with negatives. So what's cool about this is, whatever, it doesn't matter, because we already know it's going to have the same y as 1 because of the symmetry. So I put my 5 points on. I graph it through all nice. And voila, good to go. All right, let's see it go on a graphing calculator, okay? So I'll zoom on in. All right, give me 1 sec. So I'll zoom on in on my graphic calc. You know what happened? I got a notification, and I would hate to have this video I would be really sad if this video kind of shut down because I had a notification by accident. IMDb, okay. So, math over to num, select abs. Again, you're either going to get the bars or not. If you did not get the bars, you got the abs. Remember, x plus 1. I want you to go ahead and close it out, because get in the habit of doing that. In the newer calculators, like some of the ones we've seen in class, the bars go on there, so it's easy to just push out of the bars. But what if you had something outside of the bars, okay? Just be really, really careful. It can't hurt. It can only help. Please remember to do that. Let's check our work. Second table. Okay, nice. -1, 0 checks out. 0, 1. Let's move up. -2, 1. Beautiful. 1, 2. -3, 2. Beautiful. Let's check and see what the graph looks like. So I'm going to paint my graph. Wow, look at that. Nice graph. Looking pretty accurate. Let's see if we can zoom in and see if our points check out there. Sorry if my finger went in front. Nice. So look, we've got our nice little vertex at -1, 0. Nice. Intercept of 0, 1. And it goes on forever in both directions. HB wouldn't really like this, though, because it's missing the arrows on the end. Okay? All right. So remember, these skills are extremely important. I promise you, the better you can get at working through these skills, The more you can kind of fight through that frustration, I promise you it will pay off now. It will pay off down the road, okay? If you can believe in me that I want to help you and stick through this, I promise you it might not be easy now, but we practice it. You take the time. If you want to take the time, you work with me, I promise you, this will become light work. I promise you, okay? All right, so let's go ahead. I'm going to move to number 3. As I go to number 3, I'm going to mix this up, okay? I'm going to make this a 2. I did give this worksheet out. The 2 was not in there originally. I want to add a little bit of spice to it, so I'm going to put in a 2. So make sure if you're working on this worksheet, okay, you put in the 2. Otherwise, have some graph paper. I want you to pause the video. I want you to try to do this one, remember, with the 2 in front of it, like I just put in there. So it's 2, absolute value of x plus 1. I want you to pause the video. I want you to try it, and then in a moment, I'll show you how to do it. Okay, here we go. So y is equal to the absolute value, 2 times the absolute value of x plus 1. Okay, so here's what I'm going to do. Remember, what do we start by doing? We make a table. Beautiful. Good job. Make a table. Hopefully you guys said that all out loud. Make a table. Listen, I know it's going to be monotonous. It's going to be like, man, why does he keep saying this? I've taken this in high school. I've taught it at multiple levels. You got to believe me, right? You guys are going to do new stuff every year. I teach the same stuff every year. And that's why I get these little intuitions, because I've seen people not do this. I've seen them trip up. I'm trying to help you not make the same mistakes. You have time to learn this. They've already struggled with it. So think about that. All right, now what's the x in my vertex? The x is 0, because 0 will cancel out the bars. I plug in 0. Absolute value is 0. 2 times 0 is 0. What remains is 1. So 0, 1, my first point. All right, now I'm going to plug in. What should I plug in next? Well, let's work smarter, not harder. What 2 numbers are going to have the same y? What 2 x's? See if you can predict what I was thinking. I'm thinking 1 will be one of them. What's the other number that's going to have the same y as 1? Because of the symmetry. Okay, it's going to be -1, right? Because 1 and -1 are the same distance away from our vertex, the x of the vertex, which is 0. So I plug in 1. Absolute value of 1 is 1. 2 times 1 is 2. 2 plus 1 is 3. Okay, -1 is going to be the same, right? Because the absolute value of -1 is also 1. And remember, that's what it boils down to. If I get the same thing coming out of the absolute value, nothing else about the function's different. So the output will be the same, right? So once I see that I'm getting 1 out of the absolute value, right? Multiplying by 2, that's not going to change. Adding 1, that's not going to change. So I end up with 3, right? I immediately go ahead and I put these on there. Wow, look at that. Notice the slope of up 2 over 1, right? All right, I'm going to get one more point on here. How about we plug in 2? And now what's going to have the same y as 2, folks? It's going to be -2, because those are both the same distance from 0. Right? 2 is 2 away. -2 is 2 away. Now, let's go ahead, plug it in. Absolute value of 2 is 2. 2 times 2 is 4. 4 plus 1 is 5. Beautiful, okay? So 2, 5. -2, 5. Beautiful slope. We connect it. We make a line. Now, one quick observation. Observe the end behavior, okay? As x goes to infinity, y is shooting up to infinity. As x goes to -infinity, y also shoots up to infinity. So when we start to talk really and really get into the nitty-gritty of end behavior, observe that the end behavior for absolute value is always the same on both ends. So either they both point up if a is positive, or they both point down if a is negative. All right, quick calculator check. Here comes my calculator. I'll bring that in. Okay, remember, what do we hit? What button? How do we get to absolute value? First, we hit math. We go over to num. We select option 1, abs. Okay, in this case, before you do the abs, you do need to put the 2 in there first. Okay, someone's like, yeah, we're building up my math, my math skills. I got math abs, right? But you know what? What's actually cool about that is, and though you joke, the brain, right, is a muscle, right? Just like your abs. You work that brain, you make those connections, you exercise your brain, you form the connections, and then you achieve, right? That's important. Okay, so think about that. Your brain's a muscle. We know that. That's true. So now 2 times the absolute value of x plus 1. Let's do our table check. Second graph. All right, so I'm going to move this. Let's zoom on in. All right, what do we got? 0, 1, beautiful. -1, 3, beautiful. 2, 5, beautiful. -2, 5. So again, if you have a calculator on a quiz or a test, sorry if I sprayed it there. I'm just so excited. If you have a calculator on a test, go for it. Here's my only thing that I would say to you. If anything goes wrong at this point, your calculator is a computer. It does what you tell it. So if you don't put this in right, your calculator is going to be like, look, man, I'm just trying to plot. I'm just trying to evaluate what you give me. So remember, make sure that you maybe make a table. Plug in like 2 or 3 numbers before you go back and fall back on the calculator. And if you're not getting them to match up, make sure, 1, your math is correct. And if your math is correct, make sure everything's plugged in correctly. Okay, now let's see what the graph looks like. So there's our table. Let's check our graph. Oh, beautiful. Oh, that's a beautiful graph. Wow, Mr. Moray. Good thing you got a calculator to do that. All right, so let's take a look. 0, 1 is our vertex. Beautiful. And notice that nice, beautiful slope. Up 2 over 1, up 2 over 1, up 2 over 1. Now, my graph on my paper stops at 6. Okay, this graph here stops at 10. So it doesn't look exactly the same. But if I window this and I set my Y max to... So if I was to set it to look like the calculator, so I'd set it as -6 to 6. And I'd set it as -6 to 6. Now it looks exactly like the CUDA graph. Watch it. Wow. Okay. Here's another little fun fact. If you want to set your graph back to the original settings, window settings, just hit zoom and go down to Z standard. And what that does is it resets to the default of -10 to 10. So learned a lot of stuff right here, hopefully, about calcs. Remember, the more you can use those tools, because remember, that's an important practice. Use appropriate tools strategically. All right, on to our next one. I know this video is probably longer than I intended it to be, but I'm having fun, and hopefully so are you. All right, now I'm going to pose another U-try, all right? But before I do, I'm going to make this a negative absolute value of x. Let me zoom in so you can see that. It's a negative absolute value of x. So if you have this sheet, make sure you put a negative in front of it. I'll try to link to the sheet in the video. Okay, if I'm able to do that and you're able to get it, before you do the U-try, make this negative. So it's y equals negative absolute value of x plus 2. Okay, so go ahead, try the problem. Okay, try to graph it out, and then unpause, and we'll see what happens. All right, so remember, our first step is going to be, and I'm going to do this a little bit faster because we're moving through it. All right, we're going to make a table. So x, y, let's make our table, okay? So now, here we go. What I want to see us do is this. Let's plug in the vertex, 0, because 0 makes the bar 0. 2, good there, right? Because the negative won't have an effect. Now, because of the symmetry, right? Let's put our 0, 2 in there. Okay, we know we have that beautiful symmetry. Let's use the triple M, modified May method. Okay, There's the symmetry. So 1 is going to have the same y as -1. And I'll show you. Absolute value of 1 is 1. Now we use the negative on it. So it becomes a -1. Plus 2, that's -1 plus 2, that's +1. Okay, -1. The absolute value of -1 is also 1. When we make it negative, it becomes -1. We add 2, it becomes +1. Okay? So notice, again, the same y value. Now 2, that's going to have the same y value as what, folks? It's going to be -2. So I do 2, absolute value of 2 is 2. Make that a negative, add 2 to it, I get 0. And then I know -2 is going to be the same. And if you don't believe me, go ahead and plot it. All right, and now I've got my 5 points. I'm really looking, especially in honors, for a high level of precision. I think we can all do it, but I'm holding, especially in honors, I want to see a high level of precision, and I want to see 5 points. The more the merrier. Remember, I'm telling you, the more points you can put on there, I promise you it will pay off in the future. Okay? Let's just do a quick check on the table. I won't do the graph, I'll do the table. So let's wake my calculator on up. Y equals, make sure, let's say this is cleared. Remember, negative. You do not press this. This is subtract. You press this. This is negative or minus or opposite of. I do my math. I go over to num, abs. Okay? Now, I plug in my x. I close it. I add 2. I'm going to go second. Graph to make the table. Let's zoom on in and check my table. Alrighty. So I've got 0, 2, looks good. 1, 1, looks good. 2, 0, -2, 0. All looks good. Beautiful. Okay. So we're really chugging along here. I love this, okay? Now I'm going to throw another little curveball in here, okay? I'm going to come here. I'm going to take it up a notch. I'm going to do this as another you try because I think you can do this. We're really catching on, and I really believe in you big time. Look at this x. I'm going to make this x a negative x. So it's going to be the absolute value of -x plus 2. I want to see what this does. So, right, we have that. If I flip the sign here, it points down instead of points up. In other words, if I had done it without that, if I had not made that a negative, what would have happened is it would have looked like this. So what kind of a transformation is this? This is a reflection about the line y equals 2. So it's a reflection about this line. But I wonder what kind of transformation we're going to get if we flip the x to a negative x. I wonder what that would do. So take a second, try to graph it, and here's what I'll do for you. I'm going to show you what the original graph. So if I do -x plus 2, okay, I'm going to first, when we come back, I'm going to show you what that looks like, and then I'm going to show you what this one looks like. Okay, so take a second, pause, and then when we come back, I'll talk about it. Okay, so pause the video now. All right, folks, so I'm excited to see what this looks like. So remember, first we're going to look at the graph of regular, so that's just x plus 2. Like I didn't put the sign there. And then we're going to look at the negative one. So if it was x plus 2, this is what it would look like. I'd have my vertex at -2, 0. Looks something like this. So let me make sure I label it to avoid any confusion because you'll get those questions. This is y equals, so this was the one before I did any modifications, okay? Now let's look at the new one. So remember, what are we going to do first? We're going to make a table, okay? Here we go. X, y. Now, the vertex. So this is a -x, not an x. So what's going to make the inside 0? +2. Because think about it. I plug in 2. It flips to a -2. I add -2 plus 2. That's when I get 0. So if you didn't understand that, I'd recommend you go back and rewind that because You have to be really, really careful here. Really, really careful. Okay? Now I'm going to keep going. So negative 2, or rather 2, 0, that becomes my vertex. Okay? Now I'm going to plug in, how about I plug in 1? So I plug in 1. It flips to a negative 1 because it's negative x. It's not x, it's negative x. So 1 goes to a negative 1. I add 2 to negative 1. I get 1. I take the absolute value of 1. It's 1. How about 3? So here's my 1, 1. I plug in 3. 3 flips to a negative 3 because it's minus 3. Negative 3 plus 2 is negative 1. Absolute value is 1. Okay, 2 more points. 0. 0 is really nice because what's the opposite of 0? It's 0. So I plug in 0, it becomes 0. I add 2, I get 2. And there's my 2. And I'm just going to cheat and use the symmetry here. But remember, the symmetry only works if you have the vertex. I saw someone in class today be like, all right, and get the wrong vertex. If you get the wrong vertex, the symmetry doesn't tell you anything. So I recommend going until you see some repetition. And then remember, as soon as you see repeating, so let's say I had plugged in 1 and 3 first and saw that 1 and 3 had the same. So let's say I didn't know about the 2. As soon as you get repeating y values, okay, you know that the vertex will be right in the middle. Okay, so let's say, for example, I didn't know any of this. Okay, let's say we didn't know this, and I started plugging in. I was like, all right, what about, okay, let's see. I said, let's say I want 0. All right, I like 0. 0 is a cool one. Well, negative 0 is 0. 0 plus 2, absolute value is 2. All right, I don't know. Let's say I had also seen that 4. I like 4. All right, absolute value of 4. Well, 4 flips to a negative 4. Negative 4 plus 2, that's 2. Negative 2. Oh, look at that. Same y values. The only way that I could have that would mean the vertex would have to be right in the middle of 0 and 4, and that's 2. So before you pull off any symmetry, you have to know 1,000% that you have the vertex, okay? Just remember that. I'm trying to put in these little hacks, these little tips and tricks. One, to make it worthwhile to watch the video, but also to help you in the long run. So let's see what happened here. Wow. So what we might notice is, notice how this graph was reflected, okay? But instead of being reflected over a horizontal line, it was reflected over this vertical line, right? If I flip this point over the line, I'm here, right? It's a reflection, okay? So flipping this in front of the bars, that's a reflection over a horizontal line, but flipping the x inside. So flipping the sign in front of the bars, making it from a positive to a negative. But when I say that, I mean taking the a and making it a negative a, right? So like taking the 2 and making it a negative 2. If I just switch this to any old negative number, okay, it will result in it pointing down, but it's not going to be a perfect reflection. So what I mean is taking the a and turning it into its opposite will result in a reflection over a horizontal line. And the horizontal line it's reflected over has to do with this number right here. Similarly, taking this and making it into a negative, so taking the x, the thing inside the bars, and flipping the sign, will result in a reflection over a vertical line, okay? So think about it. Flipping the y versus flipping the x. All right? So now I'm going to move on to my final one. No tricks here. Just going to leave it as is, okay? I'm going to ask you to pause, try this, and then we're going to go ahead and see if it's right. Alrighty, so let's take a look at this last one right here. Again, we're making our table, leading off with our table. And I know I didn't get to do the graphing calculator on the last one, so I'll definitely do it on this one. All right, so let's take a look. Remember, your vertex, -1, because -1 cancels the bars. So -1 plus 1 is 0. Absolute value is 0. 0 plus 3 is 3. So -1, 3. Okay, remember, that's the vertex, so we'll use the triple M, the modified May method. There we go. Now, 0. 0 plus 1. 1. Absolute value of 1. 1. 1 plus 3. 4. By symmetry, -2 also is going to give me 4. But let's check. -2 plus 1. -1. Absolute value of -1 is 1. 1 plus 3 is 4. Okay? Now let's do 1. 1 plus 1 is 2. Absolute value of 2 is 2. 2 plus 3 is 5. And then -3. Again, you can show that, right? -3 plus 1 is -2. Absolute value of -2 is 2. 2 plus 3 is 5, okay? And based on our pattern, we'll see this keeps going, all right? And remember, don't forget, remember my buddy HB, she wants to see those arrows on the ends, okay? And one last thing I'll do, again, I'll check it on my calc. Let's bring in the calc. So in the y equals, remember, let's make it look the same. There's no number in front, so we won't notice no number in front. Or you could actually technically write a 1, but you could get an error sometimes if you do that. So I say if there's just a 1, you just leave it. Math, over to abs, drop my x, close my parentheses, not yet, add the 1, close my parentheses, add the 3. Let's do the table view. Double check my work, -1, 3, beautiful. 0, 4, beautiful. -2, 4, beautiful. 1, 5, beautiful. -3, 5, beautiful. And let's check our graph just for giggles. Nice, let's take a look at that. Nice, okay, so I'll zoom in a little bit more, beautiful, okay. So we got a nice vertex at -1, 3, amazing. We see the 0, 4 on there. We see the -1, 4. So remember, that symmetry is so important, okay? Really, really important. Notice the patterns, right? That symmetry has been in every single one we've done, okay? So folks, I know this has definitely been a lengthy video. I'll definitely try to put some timestamps in there to make it a little bit easier for you to look through it. I hope you found this video to be informational and kind of help guide you in the right direction in terms of helping you understand what we're doing with absolute value functions. Okay, I really recommend you take some time, look through this video, look through the problems. Hopefully you've tried some of the U-tries. Keep at it, okay? It's not easy. It's going to take some practice. But if you commit and not into falling into the tricks, but to use these tried and true, and you stay at it and you work at it, you will be successful, all right? And remember, no matter what, you can do it, all right? So thanks so much for watching this video. Feel free to subscribe to this so that you can continue to get the updates on these. And don't forget to love math, and have a wonderful night.